We present the method for locating weak zones in coal rock mass. Longwall mining is one of the most effective and fast methods for extraction coal beds. At that, rock mass stress state changes rapidly, which can induce violent phenomena, rock bursts, outbursts. Most of them are associated with discontinuities, such as thin interburdens of high ash clay coals with low deformation characteristics and stress properties. They located on coal bed host rock interfaces, weak zones. Its early detection will permit to take preventive measures in order to reduce the dangerous event risk. In longwall mining, the coal bed is divided into panels, which are excavated by coal cutter loader. In vertical section blue line, in the middle part of the sub-panels was chosen as the object of study. We developed and implemented a geomechanical model of the object. Weak zones were described by sections on coal bed host rock interfaces where shear stresses are zero. Simulation revealed that as the roadway approaches the weak zone, regions of increased tensile subhorizontal stresses arise near face breast. This can cause coal failure and induce a sudden outburst. We simulated stress state, synthesized input data for seismic tomography using empirical dependence VP on mean normal stresses, reconstructed VP distribution in illuminated domain and solved inverse problem to find shear stresses on coal rock interface. In fact, we detected weak zones where sigma xy close to zero. Lab test procedure. We manufactured artificial specimen, created weak zones on the specimen press plate interfaces, performed sounding at different levels of loading and conducted tomography on the specimen by sounding data. We developed the mass model of lab test. Using tomography data, we solved the inverse problem to find the shear stresses at the boundaries. These stresses occurred close to zero in the created weak zones. Conclusion. We proposed, theoretically substantiated and approved in vitro the method for early warning of weak zones in coal bed host rock interfaces.